So I will briefly introduce you the school, what we will do in the school, the program. So first, let me start with some figures. It's a nonsense, but let's start. So in this school, in this edition, you are more than 600 to be attendees to register on this school for 51 countries. So it's a bit more than a European school. Again, things slept over, and we forget the thing. 166 for the 14 satellite sites that we have over 8 countries in the school. So you can follow the school mainly in Europe, but also in North Africa. So you are normally 457 online, and we have also 835 accounts created for the occasion for the Grassroots Revolution on the school for the Discord. So if you want to ask questions or to ask questions for any kind of lecture or general question, you can connect to the Discord, and we'll do our best to answer them. So first now, let me present a bit the team which provide you all the teachers for this school. So it's a ROPEX project. So it's a transverse N2P3 project. So N2P3 is the nuclear particle physics project inside the CNRS. So we are about 20. So we'll have a little sample of what we can do here with nine teachers. And once we do mainly in ROPEX to foresee, to check the new technology which are coming in, to evaluate them and pick the right one for the new experiments, stuff like this. And of course, we all have different tests, and so we love many languages, different languages, so C++, Fortran, and Python. So we will have them also in the school. That's totally normal. And we have also a lot of tools. So we have performance test tools, so Valgrind, Macao, Perf, Malt also, we will have this one. For precision, we used to love to use KADNA, and also for container, we have Aptainer, Singularity, Docker, and Podman, and a bit of Kubernetes also if you have time to use a cluster like this, but we will talk about that a bit later. In terms of hardware, in terms of library, we use lots of libraries. Not all of them are in the school because we don't have time to cover everything, but we try to do our best to cover as much as possible. So Cycle, Extensor, HPX, Alpaca, Cocos, Vulkan, CUDA, HPC SDK, OpenVINO, OpenCL, OpenSCC, with a lot of hardware also. So CPU, GPU, FPGA, multi-core, many-core. Normally, we try to cover everything. So I would like to take a moment if you can show the Muppet Show blanket at the end of the auditorium. So they are not always there yet because some will come, but you have the team of this afternoon here, and we will be normally full tomorrow or something like that. So we'll see there are a lot of interesting things to tell you. So in terms of lecture, we will start simple. As always, it's better to start simple. So we will start, of course, with Adama product because you know me now. But not only, we'll talk about prediction, we'll talk about dot product and about matrix product. So the idea is to make you learn how to optimize this kind of stuff, but you have to understand how to do it, but you don't have to do it anyway because you have the MKL, you have Eigen, you have Armadillo, you have Eve, you have NumPy, you have NumPy, you have LAPAC, you have a lot of stuff. The idea is not to reinvent the wheel, but you have to know how the wheel works to be sure that you use it well. But the problem is the world is not composed of only matrix product. This is bad, but we have to adapt ourselves. So we will complexify a bit, and we will talk about the Greshcock reaction. So give the name of the school. So Greshcock discovered this reaction. And you can see that as a chemistry game of life. So the idea is to have two species, so U and V, and the point is once you have enough V around you, V transforms U in V. The same in the game of life. You have white cells. Once you have enough white cells around the black cells become white. Quite the same stuff, but you can do that with real chemicals, and that's the fun part of the story. And then we have a decay of V during the time, not reacting anymore. So in terms of mathematics, this goes like this. So we have two differential equations to solve. So it's not that difficult. So we'll have everything online if you want to get some information later. But the point of this reaction is to have something which is really easy to understand, because it's two mix of two species, but it's way hard to optimize for the compiler. The compiler has no idea what you want to do with that, and you have to give it lot of hints to explain the thing to be sure that everything will be fine. And that's the tricky part of this reaction, even if it's not really compute intensive, but it's complex enough for the compiler to have a lot of problems with that. And the point is, since it's really simple, you can have really high speed up. So for example, in the first version of the school, we had a runtime for 1,000 images in 2 hours and 45, and we end with 40 seconds. So it's a high speed up. So you can feel what's going on, how to tell the compiler to do, how to tell the compiler not to do something. So it's nice to learn. So speaking of this reaction, of course, we have to discretize this reaction because we are not in a continuous simulation. So the main tricky part of this reaction is the Laplacian here. And of course, we want a discrete Laplacian because we want to simulate it. And the point with that is once we do the computing for one cell, or one pixel in our case, because we will do some video with it, we'll have a stencil. We will access all the neighbors of this pixel. So we will limit ourselves with a 3x3 stencil. Of course, we can have some generic stencil, but you will see for the generic stencil specifically tomorrow that the compiler struggle really a lot to optimize them. So we'll keep 3x3 to be sure. And then we apply some weight on this stencil. We do our reduction, and we have our Laplacian. And the point is we need to access neighbors. So we have a lot of problem with caches, with memory, with elements. So we'll deal with that with Adrien and Vincent just after this presentation. We'll explain to you how big the problem is. And then, of course, we want to vectorize so in a generic way because we want to vectorize for CPU and for GPU. So CPU the first week, GPU the second week of the school. And the main problem is data layout, because if you don't have a good layout, you can do whatever you want, you don't have performances. And then we have to negotiate with the compiler and say to him, okay, we want the right option and we want the right int to make sure that everything is fine. And many other things, but you will have the time to discover them during the school. So in terms of languages and technology, of course, we will present C++, Fortran, Rust, and Python, as I mentioned before. The first week we'll use mainly CPUs, so on your laptop or dedicated server, or how you want to play with it, it's up to you. So we'll have C++ with TBB, with cycles, with Eve, and also a bit of OpenMP, stuff like this. Fortran with TBB also, with do concurrent, you will see that it's really powerful. Rust with its implementation, and Python with NumPy and Numap. And the second week, we will have the GPU part. So with cycle again, with ICPX, so the new name of DPC++, if you are used to use DPC++. Then CUDA and Thrust for the NVIDIA part. HPC SDK also for another trick with NVIDIA, with Fortran as well. And for us, we'll shift a bit and we'll use Vulkan, which is standard for graphics in general. So it's important also to know what's going on under the hood. And you will see that CUDA is really, really high level compared to Vulkan. Prepare yourself. Fasten your seatbelt. And finally, we will have CMake and Legate, so CuPy now because they changed the name, of course, for Python, and PyTorch and JAX, also for computing, so for the end of the week and the end of the other week. So then, since apparently you love tools, we will present you a lot of tools, because it's important to use tools even if you don't know the code that you are supposed to fix. It's really powerful. So first with performance test tools, so Valgrind, Perf, Macao, and Site, and Malt and Numap for the memory part. So Sebastian will give you a talk about that during this week. Then the compiler. So of course, do not choose a compiler, pick them all. So LLVM with Clang, Clang++, Flang, and GNU with G++, GCC, G-Fortran, and of course NVIDIA with NVC++, NV-Fortran, and NVCC, and Intel with ICPX or DPC++. So try them all and pick the best one. Choose one, and of course, if you choose one, you are wrong because you are one chance over 12, so it's difficult to pick the right one. And finally, about precision, we'll have a little talk with KADNA and classical Git, GitLab, and CMake once you want to compile. If we need to do some reminder about that, no problem. You will have all the information on time. Then I have to take a moment to present TerraTech, ORCC, and ORHPC. So we start gently, have a school, and they approach us and say to us, okay, it's nice to have 30 people for a school, but 200 is better. Okay. So we tried last year to have 200 people. We failed because we have 600. So it was a bit too much. And so in TerraTech, it's an association, association, and the goal is to do some valorization, dissemination of knowledge. So they do school, seminar, interviews. So they organize, they co-organize, and they do some publicity about a lot of schools, and they do a lot of time. They do the bridge between the academy world and the industry world, which is quite important nowadays to work together. And so they are the French antenna of the EuroCC catalog of formation for HPC, HTC, HPD, and now we can add also quantum computing for the Europe, so with 33 countries more with the France. And EuroCC is the formation catalog of EuroHPC, so if you know something like Cineca, Leonardo, TGCC, Urlicht, big Surf, big computing center like this, they come from EuroHPC, so normally you should be aware of that. So we work together on this school, and it's really, really nice to have a big team to work with this kind of stuff. Then we diffuse in multi-site. So here we are in ANSI, but of course you can follow all the lectures in ANSI, so about 40 people, so with all the teachers available for all the laboratories, so HGC Lab, LAP, LUPM, INRIA, LPNHE, and LRI. So we stream everything on YouTube and also everything on Discord. So if you have some question, please send them also to the Discord so it's easier to answer. And I will pre-shot the problem of Maria and Karim. If you are a student and you want a certificate at the end of the school, please give us a real name and really surname and the university where you are or the laboratory where you are, otherwise you cannot have a certification. So play the game, please. I saw Mary. Yeah, Marianne came here, of course. Yeah, it's better because, yeah, of course we cannot deserve a certificate for anybody, so we have to be sure that you exist and you are a student. And the last part is about Bootstrap, so the point is mainly for ANSI, not for the other, but it's nice to say also that. So the point of the Bootstrap is the very last day of the school, so the 4th of July, you can stay the whole day, and the point is we will do our best to fix your problem. So if you have questions, extra questions on your particular project, on particular technologies, we are here to help you on all the topic of the school, even a bit more, if you want to have a look. So last year it was a full day, and we have a lot to cover. This year is the same, so the same idea if you want. And then I talk about multi-site. So we have a lot of sites on the school, so 14 satellite sites, so 8 countries, so Belgium, Germany, Luxembourg, Netherlands, Slovenia, Senegal, Morocco, and France. And we have also several satellite sites in France, so Bordeaux, Marseille, Nantes, Paris, Reims, Rouen, and Toulouse. So you can also follow all the lectures from here, and you can follow also online, only on YouTube, or of course, if you don't have a big computer. You practically everything, not certain stuff about Numap, stuff like this, but you will have time to learn about that. But mostly will be quite okay to follow. So then I have to thank the sponsor for making this possible, because of course we will offer you the lunch during 2 weeks, so it's a lot. So we have to have sponsor for that. So thanks for Coderica and Intel, AS Plus, and Do It Now for sponsoring this school. And Coderica also will give you some access for the computing center for the lecture of David, I think, and for Joel also. You will see that on time this week and the week after. And finally, I will present to you a bit of Must. So as Giovanni said, we have a computing center here at Lab. So we have this kind of GPU, not many GPU, but it's enough for you to play with. So we will mainly use A100 for this school. So for the second part of the school. And we have also a formation platform. So the Jupyter Must, so the interface I presented you last week, so I can represent it if you want. And for the scheduling of the job, we use HT Condor, so it's not a classical HPC center, because they are used to use Slurm, but HT Condor is another scheduler, so you will not get lost if you want to use that. And finally, some links in the school. So you will get here the links for, here you have how to use the container. So the thing I presented last week, if you can have a look to the webinar, but you can have a look here. You have the program of the webinar, you have the program of the school to not get lost and know what you want. You can also pick them in your agenda. I forget to mention that. Then you have the example, so it's in French because I didn't have time to translate it, but normally you should be, for the other, this part here, you can have all the information available. You have the Discord here. If you want to ask question with all the lecture or general question, we try to do our best to answer as quick as possible. And I think that's it. And yeah, for the formation platform, it's only for people in ANSI. So if I click in the right button somewhere here, this one, you will get to this platform, and then you can pick Grayscale Resolution 2035, and you have a bunch of lecture. Not all the lecture, unfortunately, because it's not possible to do everything, especially because we don't have GPU on this one, but you can pick them. So for some lecture for compiler optimization for Malt or stuff like this, you can follow also and try the example live if you want. So thanks for your attention, and we are just on time. So if you have